this lecture, we are going to discuss about locus of a point satisfying the given condition. Find the locus of the points of the point Z satisfying the condition, satisfying the following condition. Number 1, arg of z minus 1 by z plus 1 is equal to pi by 3. Answer, we have z minus 1 by z plus 1 equal to z is my x plus iy, complex number z is my this form x plus iy minus 1 by x plus iy plus 1, which can be written as x minus 1 plus iy, then x plus 1 plus iy. Now multiply the numerator and denominator by the complex conjugate of denominator, that is conjugate of denominator, this one, x plus 1 minus iy. Since this is of a plus b form, a plus b, a minus b, we know the formula for a plus b, a minus b, that is equal to a square minus b square. So using these properties, here it is bracket, here it is y, there is a bracket, and so using this formula, we will get x plus 1 whole square minus I square is my minus 1, that will be plus y square. Then multiply this, x minus 1, x plus 1 will be my x square minus 1. So this will be my x square minus 1, then plus I x plus 1 y, then minus this, then plus I x plus 1 y, then I x minus 1 y minus iy minus this one will be minus this one is minus. Finally, so minus I square, that will be plus y square. Plus y square. If you expand this one, you will get x plus 1 whole square plus y square, then this is x minus 1, this is y square, so x square y square minus 1, then plus, we didn't take I outside, within bracket, this is xy plus y minus xy plus y. Okay, this cancel out. This is x plus 1 whole square, this is y square, this is x square plus y square minus 1, this is plus 2i y. Therefore arc of z minus 1 z plus 1 is equal to tan inverse y. Here y is 2y by x square plus y square. Actually this is of this form, x square plus y square minus 1 by x plus 1 whole square plus y square plus I 2y x plus 1 whole square plus y square. Okay, so my y is 2y by x plus 1 whole square plus y square divided by this x, that is x square plus y square minus 1 by x plus 1 whole square plus y square. In next step we will get, this implies arc of z minus 1 by z plus 1 is equal to tan inverse 2y by x square plus y square minus 1. According to the question, this is equal to my pi by 3. According to the question, tan inverse 2y by x square plus y square minus 1 is equal to pi by 3. This implies 2y by x square plus y square minus 1 is my tan pi by 3. And tan pi by 3 is my 60 degree. Tan of 60 degree is root 3. At the next step, you can write this as x square plus y square minus 1 root over 3. Then here 2y. Which is the required locus of the point, and it is a circle. Which is the required, this can be written as x square plus y square minus 2y by 3 root 3. If I divide this equation by root 3, then bring it to left hand side, I will get this one. Then this is minus 1 is equal to 0. Which is the required locus of the point. And it represents a circle. Take next example, next part 2. Find the locus of this points. So here you square both sides, you will get this one, z plus I whole square, and 2 square will be my 4. If I use the property of modulus, then this will be z plus I whole square greater than equal to 4. In the next step, it can be written as z minus I modulus of z minus I whole square by 4 modulus of z plus I whole square. In the next slide, it will be modulus of z minus I whole square greater than equal to 4 modulus of z plus I whole square. Using the property of modulus z is equal to z conjugate. So you will get here z minus I conjugate 4 z plus I conjugate plus I conjugate. This implies z minus I. This is z conjugate plus I. Conjugate of I is minus I. So minus minus will be plus. 4 z plus I, and this is z conjugate minus I. Now multiply, expand this, simplify this. Z conjugate I z conjugate I z conjugate I z minus I square greater than equal to 4 z conjugate plus I z conjugate minus I z minus I square, and here you will get here in this place modulus of z square minus I z conjugate plus I z minus I square is minus 1, that is plus 1. Here 4, then plus 4 I z conjugate minus 4 I z minus 4 plus 4. If I bring this to right hand side, it will be 3 z square. Then if I bring this to right hand side, it will be plus 4 I z conjugate, and this will be minus 4 I z, and this will be plus 3, and that is less than equal to 0. In the next step, it will be 3 mod z square plus, if I bring this to right hand side, it will be 5, not 4. Okay, it will be 5, not 4. It will be, when it is minus I z conjugate, it will be bring to right hand side, it will be 5, and again if I put I z, it will be minus I z, so this minus 4 I z will give you 5 by 4. This is 5 I z, this is 5 I z. So take 5 common, that will give you 5 I z, z conjugate minus z. Okay, z conjugate minus z, and here it will be plus 4, and when I bring plus 1 to right hand side, it will be 3. So this is plus 3 plus 3, which is less than equal to 0. We know that if z is complex number, z equal to x plus I y, then modulus of z is root over x square plus y square, and z minus z conjugate is my 2i y. Okay, so this will be my 3x square plus y square. Then if I take minus common, then this will be 5i z minus z conjugate plus 3 less than equal to 0. This implies 3x square plus y square minus 5i. Here 2z is 2z minus z conjugate is 2iy plus 3 less than equal to 0. I will be my plus 1. So 5 to the 10. So this one will be 10. This one will be 10y plus 3. So this is my 3 x square plus y square is less than equal to 0. Which is the required equation of the circle. That means which is the required locus, and it represents interior and the boundary of a circle. With that, I would like to conclude. Remaining will be in the next lecture.